Prove this identity. Expand the left side. Apply the Pythagorean identity. Subtract 1 on both sides. And add 2 sine x, cosine x, and sine 2x to each side. That is the double angle formula, quod erat demonstrandum. Prove this identity. Expand the left side. Apply the Pythagorean identity. Subtract 1 on both sides. And add 2 sine x, cosine x, and sine 2x to each side. That is the double angle formula, quod erat demonstrandum. Prove this identity. In parentheses, sine x minus cosine x squared equals 1 minus sine 2x. Expand the left side. Sine squared minus 2 sine x cosine x plus cosine squared equals 1 minus sine 2x. Apply the Pythagorean identity. Sine squared plus cosine squared equals 1. Therefore, 1 minus 2 sine x cosine x equals 1 minus 2x. Subtract 1 on both sides. And add 2 sine x cosine x and sine 2x to each side. Finally, sine 2x equals 2 sine x cosine x. That is the double angle formula, quod erat demonstrandum.